Today we're looking at lesson 5.5, which is on the triangle inequality. This is for geometry. The main theorem here is the triangle inequality theorem that we'll be working with, which says the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So here we're asked if it's possible to form a triangle with the given side lengths. So they give us 3 side lengths, and then if not, we're going to explain why not. And what we're doing is we're trying to compare the 3 side lengths, because any 2 side lengths should be greater than the third, no matter how you compare it. So if we do 15 plus 16, that's 31, which is going to be greater than 30. Then if we do 16 plus 30, that's obviously going to be greater than 15. And then if we do 30 plus 15, that's also obviously going to be greater than 16. So yes, these could form a triangle. The next 3, we have 2 plus 8 is 10, which is actually not greater than 11. So if it doesn't work out once, that could be your reasoning why it would not form a triangle. The next part, we're going to do kind of the same thing. They give us options for the third side, so we need to give me the option of which one could not be the value of n. So 13 plus 9 is going to give us 22. So which one is going to be greater than 22? I'm sorry, which one would be less than 22? And that would be these 3. If it's equal to, that would be not an option, so that is going to make it 22 is going to be not our value for n, because they all have to be less than the 2 sides. And then the third one, we're going to try and prove that JH plus GH is greater than JK. And it gives us that GL is equal to LK. So the first thing we're going to probably do is test out the triangle inequality theorem. And we can do JH plus GH. Besides the given, if we're going to do a 2-column proof, we're going to do JH plus GH, and that is on the big triangle. So JH plus GH, the third side is going to be GJ. So we know with the triangle inequality theorem that it has to be greater than GJ. So that, besides our given, is going to be our first step. And then we need to think about how we get GJ together, and that gives us, if we add GL plus LJ together, that gives us GJ, which is the segment addition postulate. The reason why I'm doing this is because we want to get what we're trying to prove in our actual proof here. So now we have GJ and what it's made up of. Now we can do some substituting. So we could say JH plus GH is greater than GL plus LJ instead of saying the whole thing GJ. And that's just substitution. We can do it again. JH plus GH is greater than, now, if you're looking, LK plus LJ. And that's also substitution. And now we can do LK plus LJ is greater than JK. And that's also the triangle inequality theorem. And again, we're just trying to bring the segments into the proof so that we have what we're trying to prove. So the final thing would be if we take out the middle, since we have LK plus LJ greater than JK, and we already did JH plus GH is greater than LK, we could now do JH plus GH is greater than JK. And that's the transitive property. And that concludes lesson 5.5 for geometry.